So if you're shopping for a washer dryer right now, you might run across these new crazy looking heat pump dryers, or even these 2-in-1 washers and dryers that go against everything that you've ever known about laundry. Number one, they don't have a vent. Why does that even have to be a thing? Number two, they cost way more than my trusty old school set. And number three, they seem way more complicated than they have to be. But probably the most important part, it seems like we've taken a tried and true technology and we've just overcomplicated the hell out of it. And I don't know if it's going to last.
Scott, I hear you, man. I hear this from customers all the time, and it's just not true. This technology is completely different than how you're envisioning it. It's a game changer, and it's worth every penny.
You know, the thing about this is I've taken a few of these machines apart, the standalone heat pump dryers, as well as pretty much all the combo units on the market. And where you have a nice pitch about this, Matt, I think I know the truth.
Well, so first off, how does this stuff even work?
Well, Scott, the way heat pump drying as a technology works is it's taking a technology that exists all over your home already, whether it's your air conditioning system, whether it's your refrigerator, whether it's the dehumidifier you have in your house, and applying it to a laundry appliance. So we have basically the same concept as a refrigerator. We have a cold side and a hot side. So in your fridge, the cold side keeps your food cold. The hot side moves that heat out of the refrigerator and exhausts it to the outside air.
What he's trying to tell you is the manufacturers put a dehumidifier inside your washing machine or your dryer, depending if it's a combo or not. And essentially what that means, manufacturers are always trying to look for better, faster, neater ways, I guess, to dry your clothes. And putting that dehumidification system in it allows for a lot more neat things that can happen.
So it's just basically a dehumidifier.
In a sense, yeah. It uses the same core concepts as a dehumidifier, but puts a larger emphasis on the dehumidification and the outlet temperature.
That makes sense. Because, I mean, your AC bill's always the most. Like, your AC always consumes the most amount of electricity, right? Costs the most.
So if you were to rank energy consumption in your home, it's heating and air conditioning, water heating, and drying clothes. Those are the three main energy consumers in your home in order of how much it costs to perform those functions. When number three is running a lot because you do a lot of laundry in your home, number one is going to become even more expensive.
Okay.
And when you're using an old machine, an old washing machine, instead of a modern 2-in-1, number two is going to be more expensive.
Okay.
The reason heat pump dryers can work, Scott, is because humidity sensing has gotten so good in dryers. We've graduated so far beyond the old school 2 metal strips that power traditional vented sensor dryers that we can very accurately and very tightly measure the humidity inside the drum. And we can optimize the drying performance of a heat pump to a level that wasn't really possible in previous generations of the technology.
Okay. So you have a dehumidifier inside of an appliance, and it's also kind of like a refrigerator.
Really, the interesting thing is a refrigerator, an air conditioner, none of them are actually creating heat or creating cold. They're just exchanging heat for cold. And depending on what you're trying to do with hot or cold is the difference between a refrigerator, your air conditioner, a dehumidifier, or whatever. And when it comes to that heat pump dryer, it's using both those things in tandem. One, to heat your clothes up to pull the moisture out, and the other to cool the moisture down to get it outside of the machine so there's not a vent to it. The dehumidification action or the heat pump action inside that dryer, you're pulling a lot of wattage doing that. So it does introduce a few problems that we have seen on my research with the channel. And it is kind of like a point of contention is the condenser cleaning of the product, because it does create a failure point, and that is whether or not the unit is actually going to cycle that air and exchange it properly. That was kind of the one thing that I learned from testing all these units is the condenser cleaning format. But like any appliance, especially like a refrigerator, if you don't clean the coils on your refrigerator, it doesn't last as long. You're finding out on a heat pump dryer or a combo all-in-one, same exact problem, just designated just for your all-in-one, which it can be a huge issue. With a dryer, you're trained, clean the lint out every single time, but there's a little bit more to it on a all-in-one, and if you don't do it, it tends to go worse faster.
Yeah, I mean, in my adult life, I'm pretty good at changing my AC's filter, right? But young Scott wasn't that good at it, and I have suffered some AC cleaning issues. Is that what you're going to run into with these condenser dryers?
Yes, well, condenser dryers are a similar theory to it, the heat pump dryer. The difference between a condensing dryer and a heat pump dryer is condensing dryers will take the ambient air that's in your room, inside your house, flow it over coils, and then that pulls the moisture out. But since the air isn't that cold, it won't pull a lot of moisture out, which means a condenser dryer will take a lot of time to run to dry your clothes. A heat pump dryer drops that temperature, the quote unquote ambient temperature, way down to like an air conditioner would or a refrigerator would, so it extracts way more moisture faster. The older condenser dryers would take maybe 3 hours to run a load of clothes and dry it, whereas a heat pump dryer or an all-in-one combo unit will take maybe an hour or an hour and a half. But the same problem exists on both of those systems. If you don't clean the filters, or if the condensing coil gets compromised with dirt or pet hair or debris, then that exchange doesn't happen as quickly, and then it ends up causing the whole system to go haywire because the drying times get degraded a lot, and it causes a ton of consumer complaints. And then I see people on my channel get angry saying, it took 3 hours when the manufacturer said it was going to take 1, and I've only used this 20 times.
So there's definitely maintenance required here.
Yes.
You brought up an interesting point, Ben, that I think should be something that we talk about. Condenser dryers were the original ventless dryer. And one negative point about owning a condensing dryer is exactly what you stated. The ambient room air is the working fluid. So as the dryer runs, it's going to heat up the space around it tremendously. Heat pump dryers overcome that because they package the system into a neat little box and don't exchange a ton of heat to the outside air. So like if you're in a small laundry closet with a traditional condensing dryer, you're going to get pretty roasty toasty pretty quickly. That's not the case with heat pump dryers.
Yeah, I guess I didn't even understand there was a difference between condenser dryers and heat pump dryers. I was just putting it all into one sentence. So that makes sense. They're two complete separate systems.
Yeah, the idea or the development is condenser dryers were really, like Matt said, they were the first ventless design. They were not any more or less energy efficient than your standard resistive heat tumble dryers. They would use the same amount of energy, but they would end up spreading that energy over a very long period of time, maybe 1,500 watts per hour over 3 hours, whereas the energy savings on your heat pump design, it generates the heat, but then it exchanges the cold. So you're basically taking 1 unit of energy and getting the results of 2 tasks simultaneously, since all you're really doing is just running a refrigerant pump to run the condenser coil, which the condenser coil is filled with that cold air, and then you have your evaporator coil, which is where your hot air is going to exchange at. So it's just way more efficient, and like Matt said, they're phasing them out hard and fast because when it comes to energy regulations, there's absolutely no comparison.
So the heat pump tech, this stuff is the new age technology. Basically, it sounds like the condensers are being phased out, and this is the new one coming in. I mean, how does the energy savings compare between the dryer that I've had for the last 15 years and one of these heat pump dryers? Like, is it really that big of a deal?
There are multiple factors to this, and Matt can speak to certain parts involving HVAC probably. But when I did my tests, the important thing to note is that a heat pump dryer pulls way less electricity than a standard residential tumble dryer. When you're using your standard dryer, you're plugging it into a 240 volt 30 amp plug if it's, your standard dryer. Those dryers will pull anywhere from 5,000 to 6,000 watts of electricity. So a lot. And it will run that 5,000 to 6,000 watts consistently until the clothes have mostly dried, and then it starts cycling on and off.
Now, on the flip side of that is the HVAC impact of using a vented dryer versus a heat pump dryer. So we talked about the three biggest energy consumers in any home. Heating and air conditioning is number one, water heating is number two, and a clothes dryer is number three. So 3 and 1 have a lot to do with each other when you have a vented dryer in the house.
It's a question of how long are you going to own that heat pump system? And there's going to be a lot of debate in the market about how long a heat pump system is going to last versus a traditional vented tumble dryer. I would hazard to say we don't know yet. But I know on my LG DLHC 5502, the one that I tore down and got really excited about, LG claims that the lifespan on that unit, if you maintain it properly, is between 12 and 14 years. So quite a long period of time. I don't know how many loads of clothes we could claim that will be. Let's put it at 5,000 run cycles, which is probably about 12 years if you're running 4 loads a week. And then let's take 1.5 kilowatt hours of electricity that you're saving each time you run that. That was my personal experience with my units, is I'd save about 1.5 kilowatt hours. If you multiply that out, you'd be saving about 7,000, maybe 8,000 kilowatts of electricity over the entire lifespan of that dryer. Then it's finally a question of how much is your electricity bill. I don't know what yours is in Texas, but in Ohio, where I live, it's about 15 cents per kilowatt hour. And that means that I would save about $1,100 over the entire lifespan of that heat pump system. So essentially, again, for a DLHC 5502, I'm going to have the entire unit paid back just by choosing the heat pump over the traditional vented dryer. So it's going to save me a lot of money, assuming it lasts about 12 years. Is it going to? That's going to be the great question that we have in the appliance industry over the next 5 or 10 years.
So those numbers that you just said, that's just of the actual dryer savings, right? The old school dryer running what it costs, and the all-in-one or the heat pump or whatever running and what it costs. Does that factor in any of the HVAC stuff? I don't know how you would quantify that.
In my experience with my machines, when I did some sample testing just to get a general sense, it looks to me, based on that same time scale that Ben just used, you should save in cooling costs and heating costs, depending on how you heat your home, around about $3,000 in that same time frame.
It's a big chunk.
Yeah. So $4,300 is the possible savings if that machine makes it that full 12-year design life. Now, the concepts get a little more challenging when you introduce gas dryers. Gas dryers are fueled completely differently. They burn natural gas or liquid propane. There's a lot of factors that go into the cost of operating a gas dryer versus a heat pump. It used to be a relatively simple equation because natural gas versus electric vented, gas always wins as far as cost efficiency. Flip it the other way, liquid propane versus electric. Electric typically wins. Liquid propane tends to be a more expensive fuel, at least over the last few years. So usually when customers would talk to me about, well, what should I do? I'm building a house. Should I do a propane dryer? Should I do a heat pump dryer? Should I do a vented electric? It's a murky question.
I saw Ben laughing there for a second. Is that what you saw too?
Well, I was laughing because I can only speak to the propane side of this equation because that's what the building I'm in runs off of. And my experience is using just heat pumps versus propane, even from an HVAC standpoint, is that heat pump systems are vastly more cost efficient than running propane. The installation costs are a little bit higher, but the amount of savings you get over the course of years is significant.
Makes sense. So we said a lot of stuff about 2-in-1s. I've just got a washer and a dryer like I've always had for the last 15 years. What's the difference whenever you mix it all up into one machine? I've got a washer that washes and dries now. Like, walk me through what's the difference between that and what I've got at home right now.
Okay, so the teardowns that I have done between the GE, the LG, and the Samsung system. What amazes me or surprises me the most about an all-in-one system is that they are taking quite literally an existing washing machine that they already sell and then just putting the heat pump package on top of it and calling it an all-in-one. And what I mean by all that is the procedures and teardown processes for all these units are identical when it comes to the washing machine side of it. However, when you add that heat pump system in, you are adding a lot of complexity to it, because even though we say heat pump system, that means you're adding a compressor. You're typically adding an inverter computer system to it to run that compressor efficiently. Then you're running a very large fan system to circulate all that air throughout the system to go from the drum to the condenser to the evaporator, then through the filtration system, and driving just hundreds of CFM of air through that system. So that package tends to weigh between 30 and maybe 50 pounds. And you do, as a servicer, you do have to work around that system. And it does create some unique situations that are somewhat challenging to deal with. But over time, I imagine they will be able to take those systems and simplify them to make them easier to work on. Because some of the failure points that I'm seeing with these heat package systems are how they're routing certain pieces, certain parts of the filtration system, or where the lint may be hitting a 90-degree angle that it's getting caught on during the cycle of trying to filter everything out, creating issues. So that's something that the manufacturers are going to have to work on. But again, it's just a standard washing machine with that heat pump or dehumidifier system on top of it.
All-in-ones make sense for people that laundry is not something they want to spend a lot of mental energy on. So like, if you want to be able to put dirty clothes in the washing machine and go to work and come home and have them be clean and dry and ready to put away, an all-in-one can do that. Where a traditional washer and dryer pair, you might set a delay start on the washer to have it done by the time you get home so that you can put it in the dryer, wait a few hours, and after dinner, put it away. On the other side, all-in-ones can be great for people who have a ton of laundry to get through when you put an all-in-one next to another all-in-one. If you have an existing space for a washer and dryer pair, putting two all-in-ones into that space allows you to have both running at the same time to clean and dry at the same time, so that your laundry day, if you're somebody that stores up a bunch of dirty laundry and just knocks it out on the weekend, you can have both machines running at the same time to get a final product, honestly, a lot faster than you would have been able to do otherwise, with a lot less trips back and forth to the laundry room.
So you talked about a little pain point there I've had before. It doesn't happen all the time, but maybe once a week when we're doing laundry, those clothes may hang out in that washer for a little bit longer than they should in between throwing them in the dryer, and we got to rewash them and then throw them in the dryer after that. So that probably resonates the most with me, is you don't have to worry about that anymore. You just throw it in, poke start, and you walk away. It's done. Come back and there's clothes clean.
And let me add something to that. What I found when I was testing the all-in-ones, my concept or understanding of how I did laundry to do the tests changed very radically. And what I mean by that is the all-in-ones give you the advantage of just taking the clothes, throwing them in the machine, and then since Samsung and LG have really robust applications, I just go to my phone and then tell the unit to start through the remote start option and just decide this is the time period I want these clothes to be done between washing and drying. So not only is it a set it and forget it, I can just tell the system I want my clothes done when I have time, and I know I'm going to have time at 8 p.m. tonight. The kids, I've taken care of dinner for the kids. I've gotten home from work. I can relax, maybe finish the clothes after my video game session. And when I was running these tests, I started finding myself just hammering the app and just not even touching anything.
Yeah.
And that made me think, my God, if you really use this to its full potential, this totally changes how you would ever wash or dry a load of clothes, because then you're just telling maybe the unit, I want them done when I wake up in the morning. I want them done before I go to bed, or whatever time that I know I'm going to have, because my schedule is probably predictable, and I can just program everything instead of touching the machine, other than just making sure that the clothes are loaded and the remote start option is enabled, because there are some tricks with that. You can't tell it to remote start and not have the laundry already preloaded into it, because once you choose that remote start option, it's going to lock the door so no one can noodle with the system, and then it's all driven from your phone application instead. So it's like you're set and locked in, but then you can just program it to be done whenever you wish. And
But I don't have to use the phone, right? Like, I don't use apps for hardly anything. I can run it all just from the washer dryer. I don't have to use that.
Yeah, you can run it from the UI on most of them pretty easily.
Okay.
I want to say with the LG, it was not as intuitive as the Samsung or the GE were. LG relied on the app a little bit more in my remembrance, but the Samsung and GE were absolutely programmable with delayed starts, and you could just set it for a number. But you had the luxury, if you use the app, to not only do the remote start, but you could delay it to whatever your heart's content was.
So if I can keep it running for long enough, it'll pay for itself. If I can keep it running long enough, I got to figure out how to do maintenance on stuff. I mean, they're pretty good about telling you how to maintain it, and relatively easy process.
Depends on the manufacturer.
All right.
I am part of every discussion group that I've been able to get my hands on when it comes to the different units. And the problem with the units is that consumer education is lacking, but I think that manufacturer education to the consumer is also lacking for some models. The story that I would say that I would talk about would be, for example, the GE all-in-one, the Ultra Fast. It was the first one on the market really that hit the US. My video almost has 1 million views on the GE Ultra Fast. I mean, like, when it came to the US market, it was just like an explosion. I had so many people ask me on my channel, Ben, this machine came out. I just saw it in the stores. It does all this stuff all at once. What's going on with it? And I don't go to Lowe's or Best Buy like every single week to see what's new. I'm not like super plugged into what's new. So I just had all these requests. And I thought, okay, I'm going to go try this unit and see what happened. Maybe I'll make enough money from this to justify buying this, to trying it. And what's happened over the year and a half that has occurred since that machine came out is it, maintenance wise, GE assumed that certain things were going to happen as well. And their statement or their belief system was you clean the filter every single time after you run your load of clothes like you would a traditional dryer, and that will be enough. And then it was, you need to run a brush over the coils maybe after every 50 to 70 loads. I think that was nested somewhere in the use and care guide, and that was going to be enough. The problem ended up being that there is a lot of lint that gets created away from the filter at a 90-degree curve that comes from the wash tub into the heat package system. You cannot see it. You cannot know that it's there without like a borescope inspection camera. And a lot of users over time are finding that that ball of lint will develop that has to be cleaned out with a vacuum cleaner that GE didn't tell anyone about. And it's creating a very difficult situation for consumers. The other companies out there, LG and Samsung, took a way more active approach to dealing with these things by introducing washing or condenser care systems, is what LG calls it. Their heat pump dryer and their all-in-one have condenser care cycles that will take residual wastewater from, say, the heat pump dryer, and then it will use a recirculating pump. It'll take the water out of a catch pan and then spray it on the coils to try to blow out some of the lint that will just occur that bypasses the filters.
Like a self-cleaning cycle.
Exactly. The LG all-in-one has a self-cleaning cycle, but the water distribution only sprays from one side of the box to try to clean the coils, which is, I think, insufficient. But at least they tried. They get the sticker that says, at least you tried. And that's not good enough. is what we found
Now,
out.
there's one point to add to that, Ben. I don't know if you've seen LG's pet filter as an add-on for the all-in-one and for their heat pump dryers. I think the manufacturers know it's an issue, but they also have decided that it's only an issue for certain use cases, at least in their mind. So, like, Miela's system is hands down one of the best I've ever seen because it really is designed in such a way that it's basically impossible to clog. But on the same token, I have the LG PET filter modifier for my all-in-one, and it does a fabulous job keeping the condenser clean. I just took mine apart a couple days ago to do maintenance cleaning just to see where we were at after about a month and a half of really, really heavy use. Because when we moved, we just washed everything because none of it smelled great after being shipped in a shipping container. And I really didn't have that much lint accumulation using the PET filter.
Well, also, like, another point is if you're just like, I don't know how many use and care guides I've ever read of anything that I own. I'm the guy that tries to do it first, and then, like, the last stand will be to go to the instructions to figure out how to assemble that IKEA desk or whatever I'm doing. And if that's the only place that it's being called out, like, I would never read that. I would never know that I have to do any maintenance on top of taking the filter out, cleaning it, putting it back in. So that seems like a really important part.
Most of them do have on-screen prompts that
Okay.
will tell you clean the filter on the unit after every use. On LG and Samsung's app, again, I use the app for all of these. They'll literally have a countdown on the number of cycles until you need to either run like the more advanced condenser cleaning cycle or some sort of cleaning cycle, or actually vacuum or brush things out. So they are trying to give customers prompts to tell them or explain to them that you do have to do deeper maintenance on these units. So I've really appreciated seeing that. But on other systems, specifically the GE, at least when I was using it, there was nothing, and I had to just dig about 50 pages into the manual to realize what you needed to do. And when I started reading it, I realized this is going to be a problem. So I made a maintenance video on it, and it's been like certain people's Bible, which has been hilarious to get on the Facebook groups for like the GE and see my name just constantly popping up after, or my video popping up many, many times saying, you know, that he thought this was going to be a problem. By God, it's a problem.
Yeah.
But it's because it was only in the manual, whereas the online manuals for the LG and Samsung, again, were just really so much more robust.
Yeah, that makes sense. I mean, so that's a 2-in-1, right? So a washer and dryer put together into one unit, but you can still get a heat pump dryer by itself. So, like, let's say my dryer goes down and I just need to replace my dryer, and I love my washer, and you can't convince me to replace my washer. Can I get a heat pump dryer by itself, or does it have to be a 2-in-1?
Absolutely. You can get a standalone heat pump dryer. LG and Samsung have both come out with options, and they're really cool for a couple reasons. So they're direct driven instead of being belt driven, which is actually a really big advantage for consumers because belt drive machines have implicit maintenance requirements. You are eventually going to have to replace that belt. You are eventually going to have it slip. If you have a large or heavy or bulky load, the ability to drive that load and tumble it effectively is reduced with a belt because there's always going to be a certain amount of slippage with the belt rotating against the drum. Whereas with a direct drive, you have the motor literally pancaked to the back of the drum. It all spins as one unit, and it can spin in two directions without any reversing gears or any of those shenanigans. It can spin fast or slow, so it's adjustable speed, which is not the case with belt drive. So if you run a delicate cycle, it's going to spin slower and stop and periodically rest, just like the delicate cycle in a washing machine, versus a typical tumble dryer that can only tumble in one direction at one speed. So no matter how good you take care of your wool sweaters in your washing machine and you use the most delicate, gentle cycle you can, your dryer is still going to beat it up and potentially shrink it. The other advantage of buying a heat pump dryer is it does the job at lower temperatures. So a heat pump dryer doesn't have to operate at 170, 180 degrees to effectively dry your clothes. It can operate at much lower temperatures, sometimes even maybe 10, 20 degrees more than ambient. So your delicate clothes especially are going to be much more protected. And you can see that in the end result. When you look at the lint filter of a traditional vented dryer, you see a lot of lint. And a lot of that comes from the damage of heating the clothes and tumbling them at high speeds to break off those fibers and produce that lint. You compare that with a heat pump dryer, you get so much less lint in the lint trap. And a lot of that comes from just the nature of low temperature, speed adjustable, adaptive drying versus the standard, we're going to tumble everything the same way and we're going to heat everything the same way, no matter what the fabric type is.
So I've got a wool blanket and we hang dry it because we know what our dryer would do to it if we put it in there. Ben, am I clear to throw a wool blanket into a heat pump dryer?
Yeah, the huge advantage with that heat pump dryer is that you are not having to rely on a gas igniter or an electric heater that, in order to work, has to run at hundreds and hundreds of degrees to just operate. You know, if you run the heat wire on a standard resistive heat dryer, if you looked at the temperature of that wire, it's going to be hundreds of degrees hot, 5, 6, 700 degrees, and then the air passes over it, and then it cools down a little bit as it gets to the system, but it's still blasting your clothes with 150, 170, 180 degrees of temperature, and then it's just operating under those temperatures, and then it turns all the way on and then all the way off for it to cycle on and off, and then over time it averages to the temperature that you're supposed to want or what you need. With a heat pump dryer or a all-in-one system, because you're using what I talked about earlier, it's all inverter based. It means that compressor can start up and then gradually increase its power level to get to the exact temperature that those clothes need to both dry as fast as possible, but also give you the kind of gentleness that the clothes really should have. So if you needed something that was barely above air dry, let's say 90 degrees, you can easily have that heat pump system, whether it's an all-in-one or a heat pump dryer standalone, get to that exact temperature. If you look at the data logging that I have done by throwing sensors into a dryer, you find that curve of heat is very, very gentle. It goes up very slowly, it goes down very slowly, but it can adjust to whatever in the world you want it to be.
The other thing I wanted to bring up just before we continue, it points back to something you said at the very beginning, Scott. Like, why is this suddenly a thing when the heat pump technology as a core technology has existed for so long? It's used in so many things. What we haven't been able to do is exactly what Ben just brought up. The ability of the appliance to actually sense where it needs to be and vary its performance and its output. What's powering that is really the introduction of artificial intelligence into appliances. And, AI is this big, scary term. A lot of customers are uncomfortable with the idea of their appliance being able to learn, especially to analyze their laundry habits. But it's important for these products specifically because the AI inferencing, the ability for the AI to kind of predict and make advanced decisions using sensor data is what allows heat pump dryers to operate in nearly the same time span with the results that you get versus a traditional vented dryer or versus condenser dryers of old. The AI allows the machine to sense where the clothes are at in their process of drying and vary the capacity of the output of the heat pump in accordance with it. They're able to detect the fabric type and the load type and vary the output of the heat pump in accordance with it. That wasn't possible until really the last few years to pack AI into an appliance and mass produce it.
If I tried it, Jenny has a Pendleton wool blanket. We throw it in there and it uses your AI tech to make sure that it doesn't shrink it. The negatives there are you're going to ruin her favorite wool blanket. The positives are we don't have to hang it up outside anymore and get sun beaten. So, I don't know.
I mean, think about the other side of that. How often do you end up having to buy new shirts or new work shirts or new shorts for the gym because over time they just start to kind of fall apart? It's not because of how you're wearing them, it's because of how you're taking care of them. And what's that savings really look like?
Yeah, maybe. Not sure. I have to think about that. So, all right. So we've got this new heat pump tech out there. It can be a single standalone dryer. It can be a 2-in-1, a washer and dryer together. There's some sort of energy savings on it running as a machine compared to the old school dryer that I've got. There's a HVAC thing going on where it's not sucking all the conditioned air out of the house because it's ventless. That makes sense. You can be more delicate on clothes, is what you're saying. If I can keep it running long enough, I realize those savings. I'll get all those savings back if I can keep it running long enough. Is there anything else to consider as a wrapping up kind of statement?
One
What do we
big thing
miss?
to consider is utility companies, so your electric provider, and the federal government have both recognized the advantages of heat pump technology. The utility companies care about it because it reduces demand on the grid. Our country as a whole is struggling to keep up with the increasing demand for electricity. Generation capacity is hard for utility companies to bring online. It's expensive. It can cost billions of dollars to build a power plant. It can cost hundreds of millions of dollars to add new transmission lines and substations. So anything that utility companies can sell their customers on that brings down their household demand and they can stimulate wide adoption in the area is actually a significant financial benefit for your utility provider. And so they're going to incentivize you to make those changes. We've all heard about utility rebates for things like buying a new air conditioning system with a heat pump in it. Your utility company will help you offset the costs of doing that. Buying super energy efficient water heaters like heat pump water heaters. Your utility company will help you offset the cost of that. When I lived in Pennsylvania, it was worth $125 in instant bill credit on your electricity bill. Down here in Texas, what I've seen from our utility provider, Encore, was a $75 rebate. So we're not talking about huge chunks of money, but the trend as these products start to gain more adoption, more than likely is that those utility rebate sizes are going to increase. But there's still a short-term nugget there. The bigger hit is what the federal government did with the Inflation Reduction Act. And, there's different opinions on that particular piece of legislation. Everybody's on a different side of the fence on that. But for us in the appliance industry, it's actually a huge benefit because it helps us introduce people to a technology that is going to save them money, but do it in a way that doesn't put them at a disadvantage based on the price of the products. So the Inflation Reduction Act put in place point of sale subsidies that are administered by each state's Department of Energy. Those point of sale subsidies are anywhere between $400 and $800 as an instant rebate on the purchase price of the appliance. The DLHC 5502 that we've talked about a few times, the heat pump dryer from LG, is one of the models eligible for that. The regular retail, pretty commonly sold price for that product is somewhere around $1,200. A competitive LG dryer might be somewhere in the range of $1099. So we're talking about comparison wise, not a huge gap. But now we take it $800, we get the maximum subsidy because our income level falls within a certain amount. That dryer is now $800 cheaper. So that may only cost you $200-$300 to upgrade your dryer with that point of sale subsidy.
All right. Is there anything else to consider? It's a pretty big upfront savings.
There is one thing, and this is going to circle back to something that we talked about a little bit, but I wanted to expand on. This goes back a little bit in the conversation on consumers making the choice on these machines. If you look up the heat pump dryers right now in the United States, the review scores for them actually are pitiful. I was looking this up as we were having this discussion because we keep talking about the DLHC 5502, which I love. But if you as a consumer or maybe a salesperson look up the review scores for them, they're actually very terrible right now. And the one thing that I wanted to speak to on that is that just like we've talked extensively about the maintenance and the learning curve on this new technology, is there is a learning curve on the installation practices and how you set the machine up at your house. If you looked at the reviews for these machines and you looked at all the negative 1-star reviews, the vast majority of the dislike of the machines ultimately boils down to bad practices on installation and setup of the machines. You have to set them up like you would a refrigerator, having ample space on the sides, top, and rear of the machine, but people are taking the concept of it being ventless and just kind of throwing it wherever they want to, not realizing that it does have to take ambient air in to at least start the process of the moisture removing of the system. So that's something that I think that people need to consider when selecting a machine, is to talk or educate themselves about the installation process too.
Yeah, I mean, I would agree with that. I know from my perspective, when I got negative feedback on these machines, it was because either it was self-installed by the customer and they didn't observe the restrictions in the manual on spacing around the machine. That's a great call out. The other thing a lot of people don't observe is drain hose installation. You need to make sure the drain hose is firmly seated in the standpipe if you have a standalone heat pump dryer, right next to the drain hose of the washing machine. You need to make sure that that standpipe has a P-trap so the water's not building up and backing up into the unit. And you need to make sure that the discharge level of the machines is either equal or the dryer discharge is slightly higher than the washing machine. And you're right, Ben, a lot of people don't pay attention to that, and that's why they experience poor drying performance. That's why they experience leaks and water backups. That's why they experience overall not having a fun time with this new really cool product, because they don't pay attention to those things when they either design the space for the unit or they go to install it. And even professional installers have struggled with it because I don't know that the manufacturers have done a great job at communicating some of the functional differences between these products and a traditional washer and dryer.
Well, I mean, with all the pieces that you guys have talked about, from the rebates and the running a dryer over time, and if I can get it to that 12-year mark, how much that actually equates to. On top of that, we've got HVAC savings from sucking all the air out of my house and spitting it outside. I mean, we talked about a lot of points, but, boiling it all down, taking the takeaway from all of this, like I drive a 2007 Dodge flatbed 5.9 diesel truck that's probably valued at less than what one of these things costs brand new. So, it's hard for me to take a jump on something, as expensive as some of these, but I'll try it out. I'll try it out for 1 month. We'll have Jenny throw some clothes in there and use it daily, every single day for a month. We'll see what the energy savings really is. And you're going to have to convince Jenny of this, but throw that Pendleton wool blanket in there and be ready to replace it if it shrinks it. But we'll try it out. We'll try it out and see how it plays. I think it's a good argument, at least, to see what it could actually do.
Awesome.
Well, appreciate it, guys. We will try it out and we'll keep a video on how it goes, and stay tuned for the next one where we'll talk about something else with 3 different viewpoints from it. So cool. Thanks, guys.